Hey everyone, we're going to continue our section 1.6 discussion by talking about absolute value equations. So let's get started. Recall that for a real number c, the absolute value of c is defined as negative c when c is negative, and c itself when c is already positive or 0. So these cases really just mean the following. If I have a negative number, multiply it by -1, it becomes positive. Or if I have a number that's 0 or positive already, then the absolute value of that number is the original number. So let's get a refresher. If I need to compute the absolute value of 2 minus 27, I first use the order of operations and subtract 2 from 27 to get the absolute value of -25, and that becomes positive 25. Next, take the absolute value of 3 times 2 minus the absolute value of the quantity -12 plus 6. Absolute value bars behave kind of like parentheses in the order of operations. So I'm going to combine that -12 and positive 6 first, and I'm going to multiply the 3 and the 2 together. This becomes -6 minus the absolute value of -6. That reduces to -6 minus 6, which is the absolute value of 0, which is simply 0. Now suppose we needed to solve the equation the absolute value of x is equal to 4. By simple guesswork, we can find solutions of x equals to positive 4 and -4. In other words, we know that the absolute value of positive 4 is equal to 4 and the absolute value of -4 is equal to 4. So plugging either of these values into x will give me a solution of 4. So the point is that anything inside the absolute value bars should come up to being positive 4 or -4 to be a solution for this equation. So here's the general strategy. If a is some algebraic expression and c is a non-negative real number, then we can solve the equation absolute value of a equals to c by solving the two equations a equals to positive c and a equals to negative c. So to be clear, the thing that's getting both a positive and negative version is the number c on the outside of the absolute value bars. The whole point is that the quantity a inside becomes either positive c or negative c so that we can get a final result of c. First, let's solve the equation absolute value of x plus 5 is equal to 5 for x. The point is that the quantity inside the absolute value bars, that x plus 5, needs to either become a -5 or a positive 5. So we'll split this into two cases. This gives us the equations of x plus 5 equals to -5 and x plus 5 equals to 5. These are linear equations, so solving them is pretty straightforward. We'll get solutions of x equals to -10 and x equals to 0. So our solution set to this absolute value equation is x equals -10 and 0. For our next equation, we'll solve negative absolute value of 3y plus 5 plus 6 equals to 2. This is going to require some changing because I need to have an equation of the form absolute value of stuff equals to a number to use our strategy. So what we're going to do is take the equation as it is and try to solve for our absolute value term. I'll first start by subtracting a 6 from both sides. And this is going to give me negative absolute value of 3y plus 5 is equal to -4. And then I will divide or multiply both sides by -1. You'll get the same result either way to get the absolute value of 3y plus 5 is equal to positive 4. So this last line on the left is the desired form that we want so we can use our strategy. Now that I'm here, I can split this into two cases. I'll get 3y plus 5 equals to -4 and 3y plus 5 equals to positive 4. Again, I have two linear equations that I can solve independently. Doing so is going to get me solutions of y equals to -3 and y equals to -1/3. Therefore, these are going to be the values of y in our solution set. So just to clarify, the first example of this page was already in the prescribed form. I have absolute value of stuff equals to a positive number. That's when I split into two cases. The second example just took a little bit of reworking. I had to solve for the absolute value term by getting all of my numbers to the other side, and then I could split it into two cases. This next slide shows us a couple of special cases that we need to watch out for. So suppose I have absolute value of -14y plus 3 equals to 2. To get things into the correct form, I'll subtract a 3 from both sides and find absolute value of -14y plus 3 is equal to -1. Now that's a problem. We know that absolute value quantities, no matter what's inside them, cannot produce values less than 0. Yet this equation is demanding a value of y that gives us a -1 as a result. This is a mathematical contradiction, so we'll say that no solutions for y exist. Now, in our next example, solve for x in the equation absolute value of 3x plus 1 minus 2 equals to -2. By adding a 2 to both sides, we get the equation absolute value of 3x plus 1 equals to 0. 0 is the only real number that's neither positive nor negative. I can't split this into two equations where I have a positive and a negative version. The nice thing about this case is that I get to just drop the absolute value signs and solve the equation 3x plus 1 equals to 0 and get a solution of x equals to -1 over 3. So these are our two special cases. If my right-hand side is a negative number and my left-hand side is an absolute value term with nothing else in front of it, I get no solutions. But if my right-hand side is just a 0 and my left-hand side is an absolute value term with nothing else around it, then I get to just drop the bars and solve for x. In this last case, we explore what happens when I have the absolute value of something equals to the absolute value of something else. For example, what if I had the absolute value of x minus 4 equals to the absolute value of 2x plus 1? Now imagine that we applied the same strategy, but twice, one for each side. Basically, this would yield 4 possibilities which we can expand in the following way. Obviously, these possibilities are a lot, and they don't look super nice. But if we look a little bit more closely, we notice that there's actually some redundancies here. The two top and bottom equations are actually equivalent to one another, and the two middle equations are, again, equivalent to one another. So even though I have a double absolute value situation, all I need to do is solve the first and second equation in this list. So we'll display those as follows. On the left, we'll end up with x minus 4 equals 2x plus 1, which we can solve and get an answer of x equals to -5. And on the right, we'll end up with x minus 4 equals -2x minus 1 when that negative is distributed. Now just applying some techniques for linear equations, we can get two solutions of x equals to -5 and x equals to +1.